Have you ever imagined a world where there are no numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 does not exist. So, how do you count? Or let me say, when you count, how do you record them? Let's say you try to count the number of eggs in the kitchen. Eggs in the kitchen. You probably want to grab a piece of paper and count them. And let's say there are 7 of them. You probably want to draw the 7 eggs on the paper. 7. So this is fine, but why? Because 7 is a small number and egg is easy to draw. You know, that's a simple structure, easy to draw. What if you are told to count something like printer? Yeah, printer. Because the structure of printer is complex and it is not easy to draw, you probably want to represent each printer with a symbol. Let's say a dot. 1, 2, 3, 4, 5, 6, 7. Yeah, it's making sense. But these also have a limitation. Let's assume that the printer are much. Let's say like 50 or like 100. You know, you lose organization putting 100 dots on a piece of paper. So you probably want to use some system like tally. To count 50 printer and record it in tally is very easy. All you have to just do is say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 30, 35, 40, 45, 50. So since it's already known that this is 5 in tally, so anything you write, anybody can just pick that yes, this is 5 instead of counting 1, 2, 3, 4, 5. No. So they just count in 5s, like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So that's lots more easier. And apart from these, we also have another method called Roman numerals. Roman numerals are symbols. They are very easy symbols as well. You can just say I is 1, II is 2, III is 3, IV is 4, V is 5, X is 10, L is 50, C is 100, D is 500, M is 1000, X bar is 10,000. We have C bar is 100,000, and we have M bar, which is 1 million. Yes. Anywhere you see a bar, it means times 1000. So that is about Roman. We are going to look at Roman numerals in full, even tally and every other method here. We are going to look at it in full in our next video. So just want to appreciate the evolution of counting from drawing, dotting, tally, Roman to some other numbering style before we now get to the real number we have now, the base 10 numbers. And Roman numeral can be funny at times. You know, when you want to write some numbers and you have to write symbols like C, C, L, C, X, 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 V, I. You know, all these are somehow. But there are some things that appear better, finer, and they would do better than Roman numeral. For example, we have abacus and we have counting board. They do the same thing, but at least there's an advancement. Firstly, let's look at the counting board. This is a 3-column counting board with 100, 10, and units. So if you can have 1,000, 10 of 1,000, but for this, let's just use 100, 10, and units. So yeah, it's very simple. If you want to write like 700, just say 7 on the 100. 1, 2, 3, 4, 5, 6, 7. And you leave the rest since it's just 0 and 0. But that's 700 anyway, 700. So, but when you're having something different, like you want to write 999, 999, all you have to do is just say 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 999. You say 9, 9, 9. Yeah, that's counting board. And after counting board, we have abacus. Abacus does the same thing with counting board, just that there's an advancement. Let's look at a 3-column abacus as well. So there's a rope and there's a bead. So the bead is so tight to the rope that when you hang any bead here, it won't just drop down. Instead, it will remain here. So abacus have 10 bead on each rope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the same thing here and here. That's abacus. And let's say you want to write 999 with abacus. It's very simple. This is 10, this is 10, this is 10. Just bring 9 down, bring 9 down, and bring 9 down. We have something like this. So this is 9, 3, 3, 3. This is also 9, 3, 3, 3. This is also 9, 3, 3, 3. So this is 999. This is 0, 0, 0, which means 0. But there is also a limitation here. Just imagine that you have one abacus device, just one, and you want to count this, and as well you want to count that. You can record both on the same abacus.
So you need a numbering system that can
ensure that you communicate without having to write something down. You can just say there is 999 so at so. So, but in the time of abacus, you have to just show the abacus to show that yes, there is 999. So this limitation can be solved by using base 10 numbers, something we can just say out instead of saying // like in tally, or so something you can just say out. And though you can speak Roman out, but Roman is complex. Just imagine someone is telling you that there are CCLCXXXVII people on the queue. Just imagine, it's somehow, but something you can just say easily. And that moves us to base 10 numbers proper. So in base 10 numbers, it's very easy. You can just write it down, you can just say it out. But the concept is this: you have units 10, 100, you have 1,000, you have 10 of 1,000, you have 100 of 1,000, and you have million, and you have many more like that. But when you count something, and let's say there are 999 of them, that is 999 units. 999 units. But in this base 10 system, for every 10 on the unit means 1 on the 10. So when you count 9, 10, you can just say it is 1 on the 10 and 0 on the unit. So here, how many 10 do we have here? If you divide this by 10, you have 99, and you have 9 over 10. You understand? You have 99. So just take the 99 and dash it to 10. 99, and let's remove it from here. So you have 9 left. Divide this by 10, you have 9, remainder 9. Just give this to 100. So at the end of the day, you still have 900, 910, and 9 units, making 999. It's as simple as that. When you have 7, 6, 2, 1, 8, it means you have 8 on the unit, 1 on the 10, 2 on the 100, 6 on the 1000, and 7 on the 10 of 1000. So, and many more like that. But when you are having some numbers, really big number, just imagine you have 1 and you have many zeros, like 1000 zeros at the back. It's becoming uneasy to write 1 and then 1000 zeros. No, that's too much. Instead, you want to tell someone that yes, there is 1 and then there is 1000 zeros. So how do you do that? It's very simple. Since you know that for each 0 is multiplied by 10 to give you another 0, so that means you have multiplied 10 by 10 in 1000 times, which is the same as saying 10 raised to power 1000. So you can write 1000 itself as 10 raised to power 3. You can write 1 million as 10 raised to power 6, and many more like that. Practice these questions, they would help you a lot. Thanks for watching.